application, I was informed and just noticed that the rainfall distribution actually says type 3, even though it says Orange County, Florida. So I'm going to take a look at the rainfall distribution again. So I can say type 2, and accept. And it should have been type 2. Okay? Even though it's in Orange County, Florida, it still says type 2. There are various sources out there, and this is a good resource if you're going to do a unit hydrograph on your own and you need it for a different program. This is a nice source to find the data from, and you can reference this, and it'll almost be accepted in most places because TR55 is like the backbone or the start of the majority of your programs out there, or at least it references it. Now, what I'm going to do is I'm going to show you, I'm going to go ahead and just open it up this way. And I'm looking at the storm and sanitary analysis in 2017. So it opens up. Now, if you're like my computer at home, sometimes it takes a little longer. So I'm just going to give you the basics behind it. I'm going to collapse these out, and this might be a little hard to see. So when I actually start to do design for you, I will do it on the computer at home, and you will see full screen and be able to see it easier step by step, and I'll do a project with you. But I want to show you the parts of it. There's hydraulics, there's hydrology, and hydraulics. So the hydrology portion has to do with the rainfall, which is called rain gauges, the little rain cloud, and then it has the green little box called the sub-basins. That is all of our drainage areas discharging. Now, you also have the hydraulics portion of it. And the hydraulics portion, I'm going to collapse these. The hydraulics portion has to do with nodes and links. A node is a pond or a basin, and the link, so if it's like a pond, and a link would be your structure, a pipe, a control box. So you can see that it's a conveyance pipe, a regular cross-section, maybe a ditch. It can also be pumps. Typically, I haven't seen a pumped system because the districts don't care for pump systems, because if a pump ever goes out, then it automatically floods. I know of one pumped system in Osceola County. There might be more, but I only know of one in Osceola County, and it's a permit that had been grandfathered in, and nobody wants to reapply because the district will more than likely say no because of a pump failure and flooding. So you can see that it has orifices. I know the words are tiny, but there's orifices, weirs, and then outlet, and then outlet rating curves. So you know how we did the calculation of orifice, and there's a weir, and then there's another weir at different elevations, and we went across and we added all the flows out? That's actually called a rating curve. So it's discharge versus a stage, or stage versus discharge. A rating curve is another name for it. The other thing this thing has in it, and I don't know if I'll get to it this semester, is pollutants. I know the districts are going toward making sure you account for what your pollutant loading is, your phosphorus and your nitrates are the big things. Okay, so I'm going to start with, also up here at the top is project options. Something to take a look at, because this is AutoCAD and it is with Civil 3D, you can bring plans in here and it's drawn to scale, which is sweet. Plan view truly means this is the plan view of the project that you're going to be looking at. And you can see the AutoCAD symbol down here. You also have a time series plot and the profile plot when you want to look at plan and profile sheets of water discharging through your pipe systems and your roads. So, like most programs, you have both this like toolbox or tool space area that is the same as information here on the top. Okay. So in the project options is usually where you pick, and I just double clicked, and you also have, I believe, that same here in input. So some people like to click in different ways. So project options allows you to pick the types of units you're in. Maybe you're working with a, I know that the FDOT wants their plans in metric. They may want their calculations, but I'm not aware of that. So we've got the US units. We actually want CFS. Now, the gallons per minute would typically be your sanitary pump system, like your force mains or your water mains. Open or stormwater is usually in CFS. Another thing that it might be in for your flow units is if you're doing a water resource permit. Remember what I said last time, that an environmental resource permit is what you have to get through the district to do ponds, to do construction, stormwater management facilities for subdivisions, for commercial. There's another part of it that says there's a water use permit. Okay, the water use permit means maybe I'm sinking a well for irrigation. Okay, so you have to get two different permits depending on what you're trying to do. But almost always you have to get a water management district permit, an environmental resource permit, which takes into consideration wetlands. Okay? So the reason I mention that is because the GMD is million gallons per day. Okay, and that means, okay, I'm sinking a well, and now Toho Water Authority needs water to service their providers. Okay. So you can actually use compute links and compute links in areas while digitizing. That means when I bring a drawing in, I can trace over the top of it in its true length if the drawing is to scale when it's brought in. The hydrology runoff specifications, these are the different methods. In this class, I'm going to go over, we've gone over the SCS TR55, which is the NRCS TR55. The TR20 is similar to the TR55, but for larger scale projects, typically think that way. Santa Barbara unit hydrograph, that's just another method of instead of the SCS unit hydrograph, how to do the inflow-outflow hydrographs. Modified rationale. The rationale equation is for storm pipes. Okay? They decided to modify that for storm pipes because it's in CFS and do a modified, and there's no hydrograph for the rationale. For the modified rationale, they actually put it into a basically triangular shaped hydrograph where the peak is where the time concentration is at. Okay, so we're going to just continue with the TR55 for right now. HEC 1 is now HMS. Now, the minimal allowable, I've always used a minimum of time of concentration is 10 minutes, nothing smaller. So if I had picked the modified rationale, it actually changes and says, what storm method do you want to use? So depending on how you pick it, what you're allowed to use. Now, the time of concentration, we've been using the TR55. I've always used the TR55, both here and in Kentucky. But there's also the Kirkpatrick, however you say that. I don't know if I'm saying it right. I've seen those two. These are similar, but almost always the TR55. Now, this is what I mean when I say what the district or what jurisdiction is requiring. Maybe that jurisdiction says, no, you have to use the FAA method, or you have to use this method. You just follow what is being required. So I'm just using the TR55 in both. Down here, the hydraulic routing calculations, there is a link routing for the kinematic. Now, the link routing, we're talking about, mostly when we're talking about link routing, we're talking about river routing, like through a ditch or a channel or even a river itself. We're going to leave it as kinematic wave. We'll talk more about that when we get into the hydraulics of the calculations. The Hayes and Williams or the Darcy-Weisbach equations for force main. I don't know if y'all remember, you have to take a electrical engineering class or a circuits class with voltage and how electricity follows whatever path. Pardon? Yep. So when you took that, you remember the Kirchhoff's loop, and anyway, off topic, sorry. Anyway, it's similar to that. It's you have to use, when you're working with a force main, it's all under pressure. So when you're under pressure, water can go any direction. It's not gravity fed. It's whatever has the higher pressure head that's forcing the water in the direction it's going. So imagine you have a grid system. Wherever the higher pressure is the controlling of sending water in a different direction. So if you turn on your tap, it's going to pull water. So now it's looking at all the different places that have a pull of the system. And the only reason I say that is you can actually design pressure systems in this. We won't in this class, but I'll mention it to you. But it is an option. But these are the two methods. Hazen Williamson and Darcy Weisbach. Okay. Computation and reporting options. You can do storage node exfiltration. So remember when we talked about infiltration and percolation into the ground, and we said, okay, we know that water goes into the ground that actually doesn't get part of runoff. There is a method called Horton, and there's one other, just off the top of my head, I completely forgot, but the Horton equation allows you to figure out how much infiltration or evapotranspiration that you're using. Okay, so it counts for some of the runoff to take it away. A lot of times we're very conservative and we don't even consider evapotranspiration or infiltration unless we have really good soils. And like I said, in Osceola County, most of our soils are C's and D's. In some places we have some B's, not a lot of A's. We do have some, but not a lot. Input-output files is input data in ASCII format. For the guys that had Civil 3D, ASCII format, maybe a text file, you're importing the data that way. All right, ID labels, and here's the reason, ID labels, Civil 3D loves labeling things. So these are just basic, typical standards. Prototypes, now here's something else. If you know that you're not going to use maybe a curve number less than whatever, you're going to set that, or all of your project is going to be a curve number of such and such. Maybe it's a global project and all the basins have the same curve number. You can go ahead and set, quote, prototypes. The other thing is, if you have a node, again, a pond, or we know that we're not at zero elevation because we're not on the coast, right? We know that the minimum elevation for our project might be 120 feet. It's going to be no lower than that. So you can set up some of your project already without having to go back in and modify each one of those. Another one that you have the ability to change is, for example, your basin areas. Instead of, if you want to be compatible with Civil 3D, you can say square feet instead of acres. But most of it's go ahead and leave it as acres. The roughness coefficient inside pipes, go ahead and leave that as 0.015. Some people use 0.013. Majority of people use 0.015. Inlets, when somebody says an inlet, they truly mean the inlet in roadways. Okay, so the structures on the side of the road, so you got a crowned system and the water drains. Gutter, so curb and gutter, you're actually allowed to flood part of the road in some calculations. Some places allow you to actually inundate part of the road. So there's gutter spread calculations too. So that's the in general. And the reason I'm going through most of this is because I think industry, in my opinion, industry is going toward, because Civil 3D is so prevalent, industry is going toward prepackaged. Right now, ICPR is the most used, and HMS or HEC 1 is the second one most used here in Florida right now, as I'm speaking. Analysis options. I double click on that, and here is your routings. Now, you can actually pick a start and stop date, but I'm just going to say it's 24 hours. It's one day. I don't care what actual day, year, time. Now, if you were modeling a true, I don't know if y'all remember when Tropical Storm Faye came, and it was a lot of rain. It wasn't a hurricane, but it was a tropical storm. A lot of rain came down. If we wanted to truly model that in real, reality, then we could pick dates of start and stop and actually model that. Okay. Time steps. So here's the thing. You know how? Let me go back to just to explain the concept. So here is my hydrograph, right? And I said my peak was right here. What if my time increment steps was too far apart? I might not see that peak, and then next point I plot might be over here. So I never see the actual peak. So in the computer programs, and not just the Civil 3D or the stormwater. See where I can find it? I've got too many things open. There it is. Nope, that's not it. Oh, sorry guys. It's there. Right there. Yes. I'm gonna stop closing things down. The time step that you're actually doing the calculations at need to be small enough that it doesn't miss, but it doesn't have the time gap shouldn't be in, you know, half a second, you know, whatever, because then it's going to just take longer to computate if it's a big basin. So on ours, we're going to just say our project is going to be you know, the next day. So the analysis duration is 1 day, 24 hours. You can do computational analysis, hydrodynamic analysis parameters. We'll get into this about hydrodynamics later. So I'm going to leave everything else as is. Remember the antecedent dry days? Did it rain before? Did it rain after? So you can set what you think and really model this to what type of storm or what type of what the district wants. Now, your storms are basically, you can do multiple storm events in sequence and series. We usually just do a single storm analysis with the rainfall event. Now, for time's sake, I'm going to show you in the next section how to draw the basins and input the rainfall.